All right. So today we are going to cover one of the most important topics in computer science, which is the conditional, also called a branch, also called an if statement, which is where all of the intelligence in a computer science program comes from. Without a conditional or a branch, your code would always run the same way every time and be very boring. So let's get to, we're going to just cover kind of the first part of conditionals today. We're going to visit in a little bit more detail on Wednesday, second day of the week 2, day 2. And we're also going to go over today a little bit of shortcuts, making some of the things we learned in week 1 a little bit easier, a little less typing. And we'll go over some good style guidelines in computer science as well. So in Unix, there's tons of shortcuts. Tab completion, anytime you type in a file name or a directory, hit tab and it fills in the rest of the name for you if it can. Control L clears the screen. Control U erases everything on the current line. Use up and down arrows to go through your command history in Unix. And I recommend you guys use compile main.cc to compile your code. That compiles your code using EasyPeasy, a tool that I wrote and won the best poster award of CPPCon 2016 for. Bjarne Stroustrup himself voted for me, apparently. Good guy. Good guy. And it runs Google CPP check, and then it runs G++ to compile your code. And you don't need to type all of a.out to run your code. You just type a. I have an alias set up for you on the server to do so. Now, it's kind of what I wanted to get to today before we get to conditionals, and that is the ways of doing algebra with a little less typing than before. So if we have integer health equals 100, we could, and we take some damage, we're writing a role-playing game or something like that. We take some damage. We could say health is equal to health minus 10. Now, for people that are math people, this doesn't look like good algebra, right? Because x is equal to x minus 10. Cancel off the x on both sides. You get 0 equals negative 10. It causes their heads to explode. What this means, whenever you have a single equals here, like this, what this means is compute a value on the right-hand side, in this case 100 minus 10, the result's 90, obviously, and then it will assign that value to health. So here we have made a variable named health that's equal to 100, and now we have knocked 10 off its value, and if we were to see out the value of health at this point, we would get 90. Now you might notice that I'm compiling the code with G++ instead of compile main.cc. That's because I know what I'm doing. I don't need EasyPeasy. EasyPeasy is there to find the 30 most common mistakes that new programmers make. CPP check is a tool by Google that searches for other problems that programmers make. I am so advanced, I don't need it. And then I can type A instead of a.out to run the code, and you can see that it does in fact print 90 to the screen. So this is a lot of typing, and maybe it's not that huge, but if our variable name was like super long or something, I don't want to type that whole thing twice, right? And so there is a shortcut that does the exact same thing, but a little less typing. Okay. And this shortcut exists for addition, subtraction, multiplication, division, and modulus. So here we are taking the value of health and reducing it by 10. This line of code here and this line of code here are exactly the same. It's just less typing. Okay. And there are variations for plus, minus, multiply. So if we left at multiply, we start off with health at 100. We then knock it down by 10. We're now at 90 health, and then we drink like a super health potion or something, and our health gets multiplied by 10, and our health will go from 90 times 10 to 900 health. So supercharged health this way. Okay, so this line of code, exactly the same. They both knock 10 off the health value. There is also another shortcut for just adding 1 to something. So you could do this or this, right? And so if we ran this line of code here, health would become equal to 101. And then here would become 102. And if we printed it out, it would print out 102. Right, because this line of code here adds 1 to the value of health. This line of code here adds 1 to the value of health. There's a even less typing-y shortcut called health plus plus, and that also adds 1 to the value of health. All 3 of these lines of code do exactly the same thing. They are, for all intents and purposes, interchangeable. There's probably some technical details that purists out there will say, no, they're not exactly the same. But yeah, what do? They add 1 to the value held in a variable. So we have this variable here called health, and it's getting 1 added to its value. And all 4 of these options do exactly the same thing. You can type health plus plus or plus plus health. When it's just like that on its own, there's no difference between the prefix operator and the postfix operator, which is the name of these things. All 4 of these options just add 1 to the value in health. Now, which one do I prefer? I prefer this one. This is your professor's preferred method of adding 1 to variable. Okay. So why health plus plus instead of plus plus health? It's a little bit easier to read, I think. Health plus plus, your eye starts off by looking at the variable health. Oh, it's the health variable. Okay, what are we doing with it? Oh, we're increasing it by 1. You're incrementing it by 1. Whereas when you read the plus plus first, it's not like I'm going to be baffled for like an hour, but like it's, I think, a little bit slower to read mentally. But the main reason why I like doing it this way is because the language is called C++ and not ++C. So, yeah. C++. And then the name was actually a deliberate pun. So, the C programming language by Kernighan and Ritchie in the 1970s was taken by Bjarne Stroustrup in the late 70s, and he made a new version of C that's better, and so it's called C++. It's one up on C. And that's why C# is C++++, right? Right? The hashtag, if you look at it closely, is actually 4 pluses next to each other. And it's also C# for sharp people. And it's also, if you take C and go up a semitone, that's a C#. So there's a lot of good puns in computer science. It's actually a great name. C# is a great name for a programming language. C# is, of course, Microsoft's Java, basically. So that is that. Yeah, so those are some nice shortcuts for doing arithmetic. All right, so one other thing I wanted to talk about is initializing your variables. You'll see code online doing this. You might see some code in Zybooks doing this, where they're going to be like int xyz, cn into x, cn into y, cn into z. This code is probably okay. These values aren't used. We're going to like see out the values. X. It's probably okay having those variables uninitialized, but 5, 6, 7, it prints out 5, 6, 7. It's really important that this is like bad. Okay, it's really important to understand this is bad, and it's not always immediately obvious to new programmers why this is bad. These values are not initialized to 0. A lot of times we think they are. Like if we, in fact, print these values prior to doing anything with them, they might be 0. Let's find out. Nope. The first one, in fact, was 21,993. The other 2 are 0. So, yeah. I have helped so many new programmers over the years, and so often I see a variable like this that they don't give a default value to. And my first inclination is always like, all right, somewhere in their code, they're using that variable uninitialized. And a lot of the times when they run it, it's 0. And then they might run it again. And I don't know, let's run it again. Yeah, see, it's different this time. You don't ever want to hear that from your from your program. Like it runs differently every time. Like maybe if you're like doing random numbers or something, but this isn't random. These values are uninitialized variables. Uninitialized variables are just whatever was in RAM there. So whatever bits were in RAM, that's what value they have. It's incredibly dangerous to write code this way. Don't ever do it. Always make sure your code is initialized to 0. So int x equals 0, y equals 0, z equals 0. This is how you do it, okay? You always want to make sure your variables are initialized, okay? Strings, like if you have string name or something like that, strings actually initialize themselves. Cool. So don't initialize a string to 0. It'll actually crash, I think. It will soon become illegal in C++ 23, which is something that I've been trying to push for a long time. So I'm happy about that. Yeah, strings initialize themselves, but all the other variable types, ints, floats that we've learned so far, ints, floats, chars, all of them need to be initialized to something. And if you don't know what to initialize it to 0. I mean, why not? Okay. And some people might go like, well, you're immediately reading values into this. Why do you need to initialize them to 0? Trust me. There have been so many cases. Like I'll help people on Reddit, on the CPP questions forum, and they will have uninitialized variables, and they're like, oh, but we always make sure that they're initialized first, and then something happens and they're not, and then their code works right some of the time and then crashes some of the time. Just trust me on this one. Just trust me. Always initialize your variables. The only downside is it's a little bit more typing. That's it. And I'm sympathetic to that, but equals 0 is pretty easy to type. Okay. Some students also ask, like, does white space matter? Like, you could do it like this if you wanted. I don't really like the look of it. I'm not gonna criticize you or anything, but like maybe I will. Maybe I'll think judgmentally. I don't know. But yeah, white space doesn't matter in C++. The only time it matters is that if you split a word in 2, then it probably breaks everything. So, if you were to split C out into C and out, yeah, you can see it. It doesn't like that very much. If you split int into N and T, it doesn't like that. Right? Main. Yeah. Okay. But otherwise, yeah, spaces, like you can do this if you wanted. It literally doesn't matter. A lot of people write code like this, where they have the hanging braces. That's how I was taught actually at UCSD. At UCSD, they would knock off a letter grade if they didn't like your indentation, if they didn't like your braces, if they didn't like your variable names. Letter grade off. And it was very frustrating because it would also take like 2 weeks for them to grade the homework. And in the meantime, you've submitted another homework that has whatever thing they don't like. They also wanted every line of code commented. And to me, that was kind of baffling because it's like, what kind of comment? Like, I am making an int named x equal to, like, I'm just literally repeating what's in the code right there, right? I'm making a variable of type integer named x, initialized to 0. Why do I need to document this? Like it's pretty obvious what I'm doing, And so I don't grade on any of that stuff. You are graded entirely in this class on correctness. Does your code work? Do you pass the test cases? For every test case you pass, you get a point. Every test case you fail, you don't get a point. It's as simple as that. Can you produce code that compiles correctly, that runs correctly? That's all I care about. You don't get marked down for white space or indentation. I might think judgmental thoughts if you make a variable named like, cat emoji or something like that. But I'm not going to mark you down. All right. Yeah, and sometimes people will do things like this, like they'll like if they have a big cout statement or something like that, like you'll see them kind of split it over multiple lines like that, so that you can kind of, your eyes can kind of track it and make sense of it a little better. Sometimes people will put white space, like this or something like that. Kind of break up the code vertically a little bit to make it look nice. In general, though, my rule for comments is this: like if you're doing something that somebody who's reading your code would be like, WTF? What? Huh? That's a good sign you need a comment there, right? So if we have a variable called like points per touchdown in football, let's say, which is 6, right? You get 6 points per touchdown, 1 point per extra point. But a touchdown, 6 points, right? If somewhere in my code down here, I was going like, yeah, points per touchdown equals 0. That deserves a comment, right? Because anybody looking at the code's like, why is that changing? What? Did the rules of football change? Like, what's going on here? And there might be a good reason for it. Like maybe you're like, this is a replay. Don't give points. Or, you know what I mean? Like there might be a reason why you do that. Like I'd probably do it in a different way, but like there might be a reason, right? Why you're doing something that looks bafflingly stupid, right? And if you do have something that people are going to kind of quirk an eyebrow and go like, huh? You need a comment, okay? // explain what you're doing, okay? Comments are basically why, right? So comments should be why you are doing something. What is the purpose of this, right? That's, and so like a lot of times I'll put a comment above a section and be like, this section is going to load old, game data from disk, something like that, right? And then I just have a bunch of code that's doing a bunch of loads and things like that. And people who come in after me and look at it be like, okay, that's what that's doing. They can just kind of skip over that part and get to the part they're interested in or something, right? So that's kind of my little spiel on comments. Okay. Anytime somebody's like, huh? You need a comment there. Okay. Also, variable names, X, Y, and Z are not great variable names. Points per touchdown is a much better variable name, right? So health, hit points, those are all better variable names than X, Y, and Z. I just use those sometimes because I don't have a particular like application in mind. Like if I'm just trying to demonstrate some code, I might be all like int x equals 0, c into x is equal to x times 10, cout x. If I type in 10, it returns 100, right? So this reads in a number from the keyboard. It multiplies the number by 10 and it outputs it. And I could, of course, do that instead. Multiplies it by 10. Yeah, I don't know what this is for. Like, there's no particular, like, this isn't like I'm computing taxes or anything like that. I'm just trying to demonstrate C++ code to you. And so a lot of times when I do that, I just make a variable called x because I don't know. Like, I don't know what we're doing here, right? I'm just trying to show you some code. But in general, you want to write code that's like health, and we're going to read in health, or maybe the health is 100, and we're going to take 10 damage, and this is a lot more readable, right? So our health is currently 100. We take 10 points of damage. Health is equal to health minus damage. So we just took 10 points, and our health is now 90. So that's a lot more readable. Okay, but you have to have some sort of application in mind. So a lot of times when I'm doing these lab classes and things like that, I'll just be like, all right, toss me out. Give me an idea. The 12 o'clock section today, they were like doing some sort of like Fresno animal control application with like cats and dogs or things like that. And the 12 o'clock section use like health and damage and things like that as their example for like a role-playing game or something like that. So, yeah, let's learn about conditions. So, let's say that we're making a kiosk for like SeaWorld or something like that. Like, you go up to the front gate, you park, you pay $900 for parking, and you like walk up to the front gate, the giant touch screen there. You tap it, you type in your name, your age, address, swipe the credit card, that whole thing. So let's say that we're working on part of that, and hang on one second. Sorry, there's blending going on in the background. So let's say we're making a kiosk for SeaWorld. And we're at the part where the user is going to punch in their age. Okay, so we can say like integer age equals 0. Always initialize your variables, and we can see out. Please enter your age. One thing to mention, and this is something I saw a lot of students doing today. They don't understand that when you're writing your code, it has to be between the open and close curly braces. A lot of the students in lab time today were like putting it down here, like below main, and it doesn't work. Like the code has, for now at least, has to all be inside of main. So that's the beginning of the program. That's the end of the program. So all your code has to be in the middle. First line that runs is that it makes a variable named age of type int, initialized to 0. Second line that runs, it prints to the screen, please enter your age. We're now going to read from the keyboard the age, and then we are going to vet the input. Okay. So one rule that perhaps isn't taught as universally as I'd like it to be is that you should never trust the user. Not even when it's yourself. Never trust your user. Okay? When I'm writing programs for myself, I vet my own input like 7 ways from Sunday. Okay? Like, I make sure that when I'm creating student accounts or whatever like that, I've written a program that has a shell script that creates all of your accounts, and I've got code to push out the homework and code to collect the homework. And on that note, one of the students was moving their directories around. You need to do your homework in the algebra directory, your first homework assignment here. It needs to be in there. It needs to be in a file called main.cc. When the homework's due, my autograder goes into all of your accounts. It grabs the file named main.cc in your homework directory. Your homework for this week is algebra. It copies it into my directory, compiles it, it runs it as you. Don't try and hack me. It runs it as you with your permissions. And then it runs a bunch of test cases on it. And for every test case you pass, you get a point. For every test case you fail, you don't get a point. And if you ever want to know how well you're doing, there is a program called Input Tester. And if you see all tests passed, congratulations, you have 100% on the homework assignment. There's no mystery. There's no, like subjective grading like I hated at my college where they're like, oh, well, we don't really like your white space letter grade. I don't like your variable name letter grade. I don't like your curly braces letter grade. None of that. You were graded entirely on correctness. And so if this is what you see when you run the input tester, congratulations, you have 100% on the test. Go home, go play some, video games and things like that. Path of Exile Sentinel League is ending today, so, try and get your Uber Elder clears before it's all over. So, here we are. Vet the input. Vet the input means make sure it works. Make sure it makes sense, okay? If somebody's typing an age, there's several values that I can think of that are just clearly wrong, right? So, if somebody gives me an age of like -100, you can't have a negative age, right? Like, it's just like, are you a time traveler? Were you born 100 years in the future? Like, it doesn't make any sense, right? And so, even if you're a time traveler, your subjective age, because you still lived before you came back in time. I don't see how you can have a negative age, right? And so what we want to do is with these things called if statements is we want to vet their input to begin with. There's a lot of things you do with if statements, but this is like the beginning. So you can say something like this. If age is less than 0. Okay, and so this is your first if statement you've probably seen. And here is the syntax for the if statement. It's this. You write if, then inside of some parentheses, you put a Boolean expression. A Boolean expression means something that evaluates to true or false. If what is within those smooth parentheses is true, then all of the code between the curly braces will get executed. Okay, so here we have code. We're reading in an integer into x. And then if the value they typed in was less than or equal to 5, it'll print to the screen 5 and under are free. And then no matter what, it's going to print out welcome to C world. Okay, so if they type in 10, it does not print out 5 and under are free. It just prints out welcome to C world. But if they type in 3, it will. What's that?
You're still in class.
Yeah. If they type in 3, then it will print out 5 and under are free. And then welcome to C world. Because you see what happens is if x is less than or equal to 5, it runs all the code between the curly braces here, and then it continues on its merry way down below. So this is the simplest example of an if statement. There's also something called else. Okay, not Elsa from Frozen, else. And that means if the thing inside of here is false, then run it. Okay? So in this case here, if x is less than 10, it prints yippee to the screen. Otherwise, it runs this line of code here and prints woohoo. Now 10 is not less than 10, so this code is going to print woohoo to the screen. And we will pick up more and more complicated examples on the next class. This is kind of where I'm going to stop for today so that you have a little bit of time to digest it. I'm going to give you some examples on the screen right here. Then I'm going to give you some lab time. Somebody's texting me, is the server down? Nope. I'm pretty sure that the server is up right now because I'm on it. Although, let me see if it's... Yep, server's still good. Okay, so if age is less than 0, then this is bad, man. We'll have to say something like this, like invalid age, something like that. And I could either write \n like that, or I could write double left arrow end line like that. There is a slight technical difference between the two, but more or less those two things are interchangeable. Now, if I want to quit early from the code, I can do so in a couple different ways. One is to return from main. You might have seen this in your in the magic and the demo code on Zybooks and things like that. A lot of people put a return 0 at the very bottom of main. It's actually not necessary if you don't put one there. It'll put one in for you. What it means is, quit, essentially. Leave main. And when you leave main, your program's over. So you might wonder what the 0 is for. The 0 is the error code. And so you're reporting that no error has occurred to the operating system. An alternative way of doing this is to call exit. Exit is a function that quits your program. From main, these two lines of code are exactly the same. Later on, when you learn to make your own functions, these are going to be different. Option 2 always quits. Program. Option 1 returns from a function. When you make your own function, you're going to be returning from it all the time. It doesn't quit the program. But when you return from main, it quits because main's your program. So for now, return 0 and exit 0 are the same. Just be aware that week 5 or so, you're going to learn there's a difference here. So I'm going to actually put in probably the more correct version of it like that. Okay, so yeah, an age less than 0 is obviously invalid. An age over, oldest person was like 121, something like that. So if age is over like 130, just be safe. See out. Yeah. Sorry, you are too old to go to school. And also, we'll quit like that. And it's really annoying to me when like companies do this, but like the max age is like 80 or something like that. Like my grandfather, after he turned 80, he couldn't actually punch his birthday in on a bunch of websites because they're like the minimum they allowed you to put in was like 1930 or something like that. And he's like, but I want to use your website. Like, why are you not letting me use your website? So you should be careful about that when you're working professionally. Back in the 90s, I always used 111 as my birthday for websites that I didn't care to give my actual personal information to. And it's actually quite funny now, 20-something years later, that, you know, when I try and like log in, they're like, oh, please enter your birthday to confirm it's you. And I can't punch in 111 because 1901 is not allowed as a date anymore. They don't allow you to be over 100 on a lot of websites. And I'm like, okay, well, I guess I can't log in. Okay. I didn't want to use your stupid website anyway. So, yeah, be careful of those things. 130 should be fine, I think, for most purposes. And yeah, so if we run this code, then if we type in 20, we proceed past the vetting check, no problem. If we type in -10, invalid age. If we type in 1,000, sorry, you're too old for SeaWorld. And there's one other thing that's probably a bit too advanced right now, but it's probably worth mentioning, and that is this. If they typed in not a number, see out, you must enter a number for age. So what we're doing in all these tests here is saying if they typed in something wrong, we just quit the program. Now, in reality, the kiosk would just like display a little red, exclamation mark and say like, oh, please re-enter your name. For now, we're just going to take it easy on ourselves. And if we type in that, it says, sorry, you must enter a number for age. So this little bit here, which looks really weird. And we'll talk more about that later. It's probably a little bit too advanced for today. That's a way of seeing if they typed in a non-number when it was expecting a number. And like I said, don't worry too much about it for now. It's not going to be on your quiz. So if the age is less than 0, if the age is over 30, okay, so we're pretty good. So like the vetting is done. Now let's like come up with like a ticket price based on their age. Okay, so if they're 5 and under, then they're free. Let's say. So if age is less than or equal to 5, what kinds of things can you put in here? It's a good question. You can put less than or equal to, greater than or equal to, greater than, and then double equals. Don't use single equals. Double equals, which means exactly equal to. So if your age is exactly 5, do something. And then there's not equals. And not equals is represented with a exclamation mark. So that means if age is not equal to 5. Okay. For now, we're just going to do, I think, less than or equal to. So 5 and under is free. So we'll just see out 5 and under is free. And we could do something like this, integer price. And let's actually use a float for the price. And the default ticket price at SeaWorld is the price at SeaWorld is your tickets. That's Orlando. No, we're talking about real SeaWorld, San Diego. Okay, $59.99. Okay, cool. Children under 3 enter for free. Okay, sorry. So it's under 3 too. It's not 3 and under. Okay. So under 3. Under 3 is free. Okay. And your default ticket price is $59.99. And my guess is that price is going to go up a lot in the summertime. Let's see here. Yeah, okay. No, actually not bad. Not bad at all. Okay, there we go. It's $69 on Friday and $74 on the weekends. It's like Labor Day probably, yeah. And then that day is a little more expensive. All right, well, We'll say it's 59. That seems like it's actually not too bad. I wonder if they have free admission for military. Okay, that's cool. We could ask for that. I wonder if they have like senior citizen discounts or something like that. I don't know. We'll just pretend there's a senior citizen discount. Okay. So if the age is under 3 is free, and print price is equal to 0. And then if the age is over 65, let's say 65 and up, then we will see out senior citizen discount applies, and price will be equal to $40. Let's say 42. No, I forgot the semicolon there. Always remember your semicolon. Now, a lot of people think there needs to be a semicolon here. There doesn't need to be, because the curly brace kind of takes that spot. Okay, so don't write code. Don't write code like this. Like that's nah. Don't do that. Don't do that. Okay. All right. So price is equal to 42.42 if you're a senior citizen, and then I don't know. If your age is exactly 21, then see out, you get a free non-alcoholic beer, because SeaWorld, I think it is owned by Anheuser-Busch, the company that makes Budweiser. Just bizarre, pairing of SeaWorld and beer, but, there you go. And maybe you get a special discount of price of $21.13 if you're 21 when you go to SeaWorld. All right, see out your ticket price is price. Okay. And that's it. So that would be an example of adding, very simple conditionals. Like I said, we're gonna go into them in more detail. These things are kind of split up a little bit. We're starting with the simplest idea here. So if we enter an age of 11, then you pay full ticket price. Maybe we should add like a child discount or something. No. Full price for those kids. Okay. 1, you're free. 99 years old, senior citizen discount applies. You're paying $42.42. And if you're 21, you get a free non-alcoholic beer, and your ticket price is 21 whatever. And if you're 55, it's regular price. So that, again, is how you can make your code intelligent. Now, we could add an else in here somewhere. Yeah, okay. All right, so string payment cout, please type if you want to pay with cash or credit, and cn into payment. If payment double equals cash, then cout, please use the cash here thing to pay. And then if they don't type in cash, we're going to assume they're paying with credit card, which is not a great assumption. But, it's not a great assumption, but this is your first experience with conditionals. So we'll roll with that. So if they type in cash, then it's going to ask them to use the cash reading thingy to pay. Otherwise, it's going to assume they want to use the credit card, and it will see out use the card reader to pay. And it will do one or the other, but not both. These are mutually exclusive options. So if you type in cash, it'll do the one, and it will skip over everything in the else block. Cout. Welcome to C. Okay. So if they type in cash, it's going to print to the screen. Please use the cash reading thingy to pay. And obviously, I don't have the cash reader here, so we'll just pretend they paid. And then it's if they typed in cache, it's going to print this to the screen, and it's going to skip over all of that code in the else block. It either does the one or it does the other. It doesn't do both. Okay. If they type in credit card or anything not cache, then it does the credit card branch, and it skips over everything in this branch. They're mutually exclusive. You do one or you do the other, not both. That's how else works. Okay. It's not Elsa from Frozen. It's else. Oh, and some student asked, what does why do I type !G? So that's a Unix shortcut that stands for run the last command that I gave that began with G. And so in this case, it's G++. Okay. GG is the same thing. So there's a alias for GG setup. It's a little bit safer in case you're running other commands that start with G. But it runs the last G++ command that I ran. It's pretty fast. If you see me doing Unix, all the commands I type are like 2 letters. And there's a reason for that, because it's fast. I hate wasting my time. And so like when I'm coding, I don't want to be losing any time compiling my code, typing things, like at all. I want to be on point, on task, on fire, working, getting my stuff done, figuring out what's wrong, coding new stuff, testing it, verifying, running it, boom, 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 boom. And I don't want to be sitting there going like, no. Okay. Speed. I used to do coding competitions, which was actually really good at improving the speed that I built. And that's it for today. So for your lab time,
Is it good?
that's good. It's mango lassi. Very nice. For your lab time today, I'd like for you to do the following. Ask the user for their username and password. If the username is anything but hackerman, quit. Yeah. Print access denied and quit. If the password is anything but hunter2, print access denied and quit. Otherwise, print you have access to the mainframe. Yep. Computer science, you always have to say, I'm in. Hacking into the mainframe right now. So if you don't get these references, Hackerman, Hunter2 is a meme. That's a meme. Look them up. Pretty funny. I'm not going to get a YouTube copyright strike by showing them. One of my favorite bad hacking scenes, which isn't exactly related to this, is the NCIS 2 Idiots, 1 Keyboard scene, which is one of the most infamously bad computer science scenes ever. You have 2 people typing on 1 keyboard at once. Okay, that's it for today. We will reconvene in 2 days and learn more about conditionals then. Thanks, everyone. And I hope you have a great time working your homework. Zybooks and algebra are both due on Friday. There's going to be new Zybooks going up in about 10 minutes. That'll be on conditionals. Start working on that, and then you're going to get your next conditionals homework. Probably on Friday. Maybe Wednesday. We'll see how it goes. All right. Peace out.